You have to actually draw the graph here. It is saying sketch the variation of these quantities with distance. So the arm PQ of the rectangular conductor is moved from 0 outwards. Uniform magnetic field is perpendicular to the plane. It extends from 0 to B. See, you'll have to use this Flux's normal equation. You have to use over here. Flux is B dot A. Sneha, listen. Flux is B dot A. So area will be what? It will be BL, L into V. You have. So area is LVT. So flux becomes what? BLVT. Right. BLV into T. That is your flux. See, rod comes back, slope is negative. Okay, don't even do it like this. It will become. See, flux is minus d phi over dt, right? So slope of the graph is negative. You get a negative slope of the graph. Then what will happen? After this, when you're shifting it back, this is no given this rectangle rod, when you're shifting it ahead. So again, you see your EMF that becomes positive. EMF will again be negative, minus d phi over dt. Fine. Now then again in another time interval, after B to 2B, all the magnetic field lines have ended. Magnetic field lines तो B तक ही है ना, उसके बाद तो नहीं है. So till B only you have the magnetic field lines, and after it the magnetic field lines are not there. So it means now your graph will be positive afterwards. So it means it's basically like this. Initially, then it is constant, then it is declining. Fine. Like this, you are having the graph. If you have your graph, no, this is your figure. This was your conductor. Here is this point 2B, here is this point B, and this is the 0, this is the 0 point. And rod is this is moving with velocity V. So this is written, arm PQ of rectangular conductor is moved from 0, this is 0, outwards. From 0 it is moved, right? From 0 it is moved. Uniform magnetic field perpendicular plane extends from this region only. In this region only you have the magnetic field lines existing. Only arm PQ presents substantial resistance. Consider situation when the arm PQ is pulled outwards from 0 to 2V and then is moved back to 0, back to this initial point with a constant speed. You have to obtain the expression for the flux, induced EMF, the force necessary to pull the arm, and the power dissipated as joule heat. Then it says sketch the variation of these quantities with distance. See, flux, simply do this. You have phi is equal to B dot A. So if you put B dot A, that becomes BA cos theta. Sana, there's a question that Sneha had sent on WhatsApp. So she is getting the question, that question only I'm discussing with her. So this is BA cos theta. So this becomes what? BA cos 0 degree. Angle is 0. That becomes 0 degree. Now you have to find out what is this area of the rectangle that is enclosed. So B is mentioned to you. Length of conductor is not given. Let's say some length of conductor is there, because nothing is mentioned no regarding the length of this. No length is mentioned, right? So see, for till X is equal to less than B, your flux is there. Flux stops changing because it is under constant field. But when rod comes back, then the flux gets decreasing. Start. Magnetic field lines have ended. So when the rod is pulled back, magnetic field lines decrease. So your flux decrease. So here what will happen? Initially you have the graph like this because slope is positive constant positive. This is the graph for your magnetic flux. Why? Initially, when it is from 0 to B, you have constant magnetic field lines. Then it starts moving in this region. From 0 it starts, so it increased. See, your conductor is initially here. From 0 it is going to B. Right, it has just started. So no field region to field region, flux increases. Then flux moves over here. This is constant region, constant graph. Then when the rod comes here, then there is no flux, so it decreases. First tell me, this graph is clear, Sneha? Okay, now based upon this graph, you have to write other things. Like if this is your graph between flux and time. So see, if here the slope is positive, so EMF will be negative. Slope is constant, there is no change in EMF. EMF will be 0. Second EMF will not be negative, it will be 0. It is decreasing, so negative into negative will give you positive. So if you plot the graph of EMF, it will be initially it is negative, then it is 0, then it is positive. Like this graph you will get for EMF. Understood? For what all things are there? Power will remain constant because power's formula is what? Power's formula is B square L square V square by R. So this will be constant. Powers will be constant. So same thing only. Whatever formula there, that you write it. And accordingly, the graph you can plot if you write it for flux. Clear, Sneha? Okay. So yes, class, revised this or not? In the last class, we had started with microscope. So soon you'll be having a test also of microscope. Be prepared with it. Not microscope, the complete ray optics only. Next Monday, on the coming Monday you have. Now see, we have just a quick summary of what we did. Two things are there. Two things are included. Fine. Simple microscope and compound microscope are there. Simple microscope has two cases. Compound microscope has two cases. First is the case when your final image is formed at least distance of distinct vision. And what is the least distance of distinct vision, Sana? Least distance of distinct vision. How much is it? (25 centimeter). Good, Sana. And other cases when your final image is formed at infinity. So if your image is formed at least distance of distinct vision, the magnification for simple microscope is d by f plus 1. For infinity, remove this one, only d by f. Coming to compound microscope, you again have both the cases when your image is formed at least distance of distinct vision and when your image is formed at infinity. For compound microscope, at least distance of distinct vision, just multiply minus V naught by U naught in front of whatever you have written for simple microscope. You had D by F plus 1. So multiply minus V naught by U naught, D by Fe plus 1. For the compound microscope at infinity, minus V naught by U naught multiplied with D by Fe only. All right, this is the way to remember it and learn it. Do you people have any idea about telescope? Is telescope included in your syllabus or not? Because if telescope is there, then we'll complete it in the next class. Because rest of the things will be over today. Only Prism is left. So if you have any information about telescope, let me know for your CBSE board exams. It's included, no? Because last year also it was included. So it included for me means CBSE. If it is done in your school, then it will be included in CBSE. Because schools do not do the extra things, no? Yes. Here we do some extra things, but in school you just stick to your syllabus only because less time is there in school. So, all right, we'll do telescope in the next class only. We'll do it. Let's complete with prism today. First, before that, we didn't do any question on this. So let's practice a question. Then prism is a small topic, but a very important topic. This says that you are given two converging lenses of focal length 1.25 centimeters and 5 centimeter to design a compound microscope. So here your focal length for your objective lens is given as 1.25 centimeters. Focal length for your image is given as, for your eyepiece is given as 5 centimeters. You have to find out angular magnification if final image is at least distance of distinct vision and when final image is at infinity. See, for this question, no, least distance of distinct vision will already be 25 centimeters. F naught is given to you as 5 centimeters. U naught, I have not written, no, object distance. Object distance is 5 centimeters. This is a part of question only. U naught will be 5 centimeters. V naught is not there. How will we calculate the magnification? Because without V naught, you cannot use the formula for the magnification. So see, if I have F naught, if I have U naught, can I calculate V naught by any method? V naught can be calculated by any method or not? F naught is there, U naught is there, V naught can be calculated or not, class? Or it's impossible to calculate V naught using this much data? Lens formula, good Sana. Definitely we'll use lens formula only. Now I'll start taking your Viva in the classes, then I think only you all will start responding. And that too, I'll ask you all to open your cameras and then answer the questions. If you know some answer, just respond. Even I give you the allowance to answer in the text. Answer me through the text. But if you will not interact, then how will this work? Otherwise, certain topics you will forget. So see, 1 by F naught is 1 by V naught minus 1 by U naught. In lens formula, we put the sign conventions. Lens formula requires sign convention. So we'll put everything here with the proper sign convention. 1 by 5 is equal to 1 by V naught minus 1 by minus 5. Like this, we'll put proper sign conventions will be there for it. So this will be what? 1 by, no, not 1 by, F naught is 1.25. F naught is 1.25. So this will be 1.25 only. So this becomes 1 by V naught is there. 1 by V naught will be 1 by 1.25 minus 1 by 5. Then you'll have V naught, 1 by V naught as 4 minus 1 by 5, that is 3 by 5. So V naught will be 5 by 3. You have the formula for the first part. You know the formula. Magnification is minus V naught by U naught D by FE plus 1. For the second part, you know magnification is minus V naught by U naught D by FE. Just put it in here. All right, note it down. Yes, Sana, good point that you have pointed. For lens formula, we'll use sign convention. We'll use minus u. But for your magnification, do not use negative. All right, negative, positive, whatever it is given in the question, be it as it is. Just use the magnitude. All right. Okay, Khalid has answered also. -2, -5. Khalid has also submitted his assignments as well. Yes, -2. Good, Sana, correct. Others are also submitting or not? I'll just check with the assignment record of yours. But recently, I think very few have submitted. Submit your assignments whenever you have time, at least during the weekend you can. Let's start with Prism. Before we start with the actual calculation of Prism, no, just understand one thing. This assignment is uploaded on the site. I think it is sent through the WhatsApp as well. WhatsApp, I'm not sure, but on the Learnivio portal that is there, it is uploaded. See, Prism is not just that triangle part you see. Prism is just not this that it appears to be. Prism actually is, it's actually not a 3D triangle which you can see. We are just able to see this part of Prism. This is the back side of Prism. In between, the prism is connected like this. It means these are the three rectangular faces which are joined by the two triangular faces. Fine. So this is the triangle face. And whatever we'll study from this face only, because that will help us define the rest of the face. But in reality, this is how a prism is. You will have the practicals also, I think, of prism. You have it to calculate the angle of deviation and all and plot the graph. This practical is there in CBSE. So this angle, no, that is formed by this inclination of these this rectangular plate and the other rectangular plate. This is known as angle of prism. And these are the refracting surfaces. Where this is the rectangular part and this is the rectangular part. So I've already written this prism is wedge-shaped portion of transparent refracting medium bounded by two plane surfaces inclined to each other at an angle, at a certain angle. And that certain angle is known as angle of prism. Now we'll be just focusing on this part. Angle between these two plane surfaces. It's like this is a rectangle I have, this is a rectangle I have. I've inclined it. So this angle that is formed here at the tip, this is known as angle of prism. Two rectangles like this. So I've joined it with a base and two triangles cover it. Now this is angle of minimum deviation. Before minimum deviation, normal angle of deviation, what is the angle of deviation? Minimum deviation, we can figure it out later. Firstly, this is important to know what is angle of deviation. For that, we have to have a proper figure of triangle. Do one thing, just note down this introductory 2 lines so that we can start fresh. Angle of deviation, angle of minimum deviation. I think till now you all must have written. Now let's start with proper derivation that is there. This is the angle of prism, fine. So incident ray has fallen on this. This is the normal. So this angle is known as angle of incidence. It gets refracted and then again a normal here, and this gets again refracted. Let's say this is R1, this angle is R2. Just naming the angles, rest of the phenomena same. Just naming so that a standardized name can be applied. Let's say this point is A, this is B, this is C, or Q, R, N, some random point I've taken. And see, what is angle of deviation? Understand that. This ray had to pass like this if the prism was not there. If the prism didn't refract the incident ray that was coming on this surface, this incident ray is coming. If this didn't refract it, then this light ray would have passed straight away. Now what is happening? Light was going like this. Fine, this was how light was going. Now light's path is like this. So what is angle of deviation? This is angle of deviation. By this much angle, the ray has deviated. Ray was going like this. This much angle, it has deviated from the original path. This was the original path, so this is the deviation in it. Whatever is the angle light ray was going, deviation has occurred. So this is angle of deviation, and we'll calculate this only. Let's say this is some angle 1, some angle 2. Now, C class. If you look at R1, R2 and this triangle, in triangle QNR, can you notice R1? Let's say this is some angle X. It will become easier to write it all the time. R1 plus R2 plus X will be equal to 180 degree. Angle sum property of triangle. So R1 plus R2 is equal to 180 minus X. Just have a look at this quadrilateral. AQRN. This is angle of prism A. This is X. In quadrilateral, the opposite angles make the 180 degree sum of each other. So this is angle of prism plus X gives 180 degree. So you can say angle of prism is 180 minus X. A is also equal to 180 minus X. R1 plus R2 is also 180 minus X. So from here you can conclude R1 plus R2, this is equal to A. This is one of the important equations that is required for your calculations everywhere. This is the first important equation that is obtained. First, tell me, clear till here or any doubts till here, or should I repeat? These two lines are clear to you or not?
Yes, teacher.
Clear? Okay. All right, class. Am I audible to all of you? My voice is audible? It's audible, okay.
Yes, teacher.
Okay. I, angle of incidence, I have written it as I only. The angle of incidence, I have written it as I. Emergence, because this is the emergent ray, that's why. Okay, if it's clear till here, then fine. Now see what we'll do. If you look at this angle of deviation, look here, this is actually what? This is angle 1, this is angle 2, and this is the deviated angle. So it means angle of deviation is actually angle 1 plus angle 2. Let's see, angle 1 and 2 are what? Now clearly look at this, because if you miss it, you'll not be able to understand how things have happened. Look here carefully. If this is angle of incident I, look carefully what is this angle. If this is angle of incident I, what is this angle? Have a look at the figure and answer, class. That will also be a very good, Sana. Because vertically opposite angles. Yes, vertically opposite angles. If this is I, then this is also equal to I. And this angle is made up of 1 plus R1. So can't you say 1 plus R1 is actually equal to angle of incidence only? So C class. 1 can be written as what? R1 plus angle 1. Your angle 1 plus R1 makes your angle of incidence. So angle 1 can be written as I minus R1. Similarly, angle 2 plus R2 can be written as emergent angle. So angle 2 can be written as emergent minus R2. Put these in these, value of delta. Angle 1 is I minus R1. And angle 2 is E minus R2. I minus R1 plus angle 2 is E minus R2. Just rearrange it. I plus E together, minus R1 minus R2 together. Just take minus common. What is left? R1 plus R2. Just now we have derived R1 plus R2 is angle of prism. So delta is I plus E minus angle of prism. Just mentioning what all terms are there. Delta is actually angle of deviation. I is angle of incidence. E is angle of emergence and A is angle of prism. Fine. This is one very, very important equation that is used, that will be used. Now, minimum deviation. Coming to the point and the fact that we were discussing regarding minimum deviation. This is normal angle of deviation. This is not the minimum value. What about the minimum value? See, for the minimum deviation, there are two conditions. Then your answer then will be quickly solved. First condition is angle of incidence becomes equal to angle of emergence. Second condition is R1 becomes equal to R2. So in your equation, delta, this is equal to I plus E minus A. I plus, instead of this E, I'll write I again minus A. So delta becomes 2I minus A. From here, value of 2I, how can I write this value of 2I? I can write this value of 2I as delta plus A, right? Angle of deviation plus angle of prism. So I is what? I is delta by plus A by 2. This is I. Fine, class. Now see. Other equation was R1 plus R2 is equal to A. So R1 and R2 both are equal. R1 plus R1 is equal to A. I can write 2R1 is equal to A, or I can write simply R is equal to A by 2. Just I have value of I have value of R. Here you have the value of I. Here you have value of R. If you apply Snell's law, N is equal to sine I by sine R simply. So refractive index is equal to sine I is delta minimum angle of deviation plus angle of prism by 2 divided by sine A by 2, because that was the value of R. This is the final equation of angle of minimum deviation using refractive index. So first note down this part, then continue over here. Then I have written a numerical that we'll do. At least 2 to 3 numericals we'll do based on this, because this is very important topic. I'll ask you all, I think, write it as important as well. All right, note it down. Wherever you get stuck, let me know. I'll just repeat the steps quickly so that it is easier for you to revise it. Draw this triangle, same things, angle of incident coming, getting deviated, I is there, E is there, R1, R2, angle 1, angle 2. For R1 plus R2 is equal to A, use the exterior angle property and the quadrilateral property. R1 plus R2 will be equal to 180 minus X, and angle A is also 180 minus X. You will get the equation. Then for the second case, delta is equal to 1 plus 2. 1 is R1, I minus R1, 2 is E minus R2. Put it in the equation, you get the value of del. For minimum, just substitute I is equal to E and R1 is equal to R2, you will get the equation back. Still, wherever you are not able to understand, let me know. At that point only, I can repeat also the whole thing, because this is an important topic from the complete chapter Prism. Now we'll just do numericals. Prism will be over. All right, so if you have any queries, let me know. Okay, let's practice some numericals on this. Calculate refractive index of material of an equilateral prism for which angle of minimum deviation is 60 degree. Equilateral prism means A is 60 degree and delta minimum is also 60 degree. Refractive index you have to find out. See, refractive index is what? This is sine delta minimum plus A by 2 divided by sine A by 2. Delta minimum NA and N, these are only three quantities that are required. So for finding N, you need two, no, out of all these three. So yes, when you put it, N is equal to sine, delta minimum is 60 plus 60. Plus 60 by 2 divided by sine 60 by 2. So N is equal to sine 120 by 2 sine 60 degree divided by sine 30 degree. So this is equal to what? Root 3 by 2. This becomes half. So 1 into 2. N is root 3. All right. Quickly note it down. One more question, let's do. So this question says, ray of light passes through an equilateral prism. Means here A is still 60 degree. Equilateral prism is there, no? But it says angle of incidence is equal to angle of emergence, and angle of emergence is given as 3 by 4 of A. That is 3 by 4 of 60 degree. This is what? 45. 4 into 15, 15 into 3. That is 45 degree. And if I is equal to E, then I is also equal to 45. So 60, 45, 45. Then it says angle of deviation. So angle of deviation is what? I plus E minus A. This is equation just now we have derived it. So I is 45, E is 45 minus 60. So 30 degree, I think. 90 minus 60, which is equal to 30 degrees. Second part says refractive index of prism. For refractive index of prism, see, refractive index is directly given by sine A plus delta minimum by 2 divided by sine A by 2. So sine A is 60, delta minimum we have calculated 30 divided by 2 divided by sine A is 60 by 2. So this becomes 90 by 2, that is 45. So sine 45 degrees divided by sine 60 by 2, that is 30 degrees. Sine 45 is 1 by root 2, sine 30 is 1 by 2 only. So you get 2 by root 2. Yes, root 2. Answer will be root 2. Because you have 2 by root 2, if you rationalize it, up and down multiply by root 2, this becomes root 2 only. So n is root 2. All right, note this question as well. One more thing, class. A modification that can be asked over here is calculate the speed of light in prism. So if this is asked, calculate speed of light in prism. See, refractive index, you can write it as C by V. So speed of light in prism, V can be written as C by N. So velocity can be written as 3 into 10 to the power 8. Refractive index you've calculated, that is root 2. So question will not be directly just like this. Question will be the above question which you have written, the complete statement. At the instead of calculation of refractive index, it will ask you to calculate the speed of light. So this much meter per second, whatever is the answer, you have to mention. All right, add it. One last question we'll do.
Teacher, root 2 is like the default value of n everywhere, or like we took it from previous
No.
question?
This is actually a part of this question only. This is what's that type
Okay.
thing. You can make it as third part only. Root 2 is not there. Definitely root 2 you have to calculate. It can be any value. It's actually a part of this question. I'm just giving you an example. Like this way also it can be asked. V is velocity. Refractive index is speed of light in air by speed of light in some other medium. So speed of light in vacuum is 3 into 10 to the power 8. And speed of light, speed in the other medium we have calculated. One last question, then we can move further. Calculate value of angle of incidence when a ray of light incident on one Face of equilateral prism produces emergent ray if it just grazes along the adjacent face. This means what? C class. This is a angle of prism. Equilateral prism, then again 60 degree. Incident ray is there. This is normal. It gets refracted, and instead of coming out, it just grazes along. It means even if you draw up the normal, the angle of emergent here is 90 degree. This is what is meant. This is R1, this is R2, and refractive index is mentioned as root 2. This time refractive index is mentioned root 2. It's a coincidence that this is again root 2. Do not remember root 2. Now let's say this is some point, A point. Let's say this is angle of prism 60 degree. This is some A point. This is some B point. If you apply Snell's law here, so the refractive index here is 1 into sin I is equal to root 2 into sin R1. Root 2 into sin R1. From here, we just have to calculate incidence angle, no? So sin I is equal to root 2 sin R1. I can be written as sin inverse root 2 sin R1. Now tell me class, is this answer fine? Should this answer have some more quantities? This is enough, this is correct, or this is insufficient? What do you think about this answer? Angle of incidence was asked to us simply. This is the question. Angle of incidence was asked. I have calculated angle of incidence. So is there any issue in this answer, or this answer is fine? This is what we wanted to calculate. Yes, Khalid. Salman.
Sir, maybe incomplete the question
Why?
because we didn't find the value of R1, right?
Perfect. Very good. See, R1 is not given in the question. R1, so I've written it on my own. No, R1 and R2. These are not no variables. What I wanted to tell you is that whenever you're solving questions and you have any values and any variables that are of your own, so mention it and solve it, and at the end, let know what your final answer is. Whatever is your final answer, and the final answer should have only the variables that are given in the question. Sometimes it is mentioned angle of this is A, the value is X, like this. If something like that is mentioned, then mention it. Otherwise, do not. See, for R1, now what we can do, apply Snell's law at B point. So that will be root 2 into sine R2 is equal to sine 90 degree into 1. Right, root 2 into sine R2 is equal to 1 into 90 degree. So this becomes sine R2 is equal to 1 by root 2. So R2 will be 45 degrees. Directly R2 will be 45 degrees. Now see, R1 plus R2 is equal to angle of prism as well. So R2 and R1 we can say R1 is equal to A minus R2, that is 60 minus 45, so 15 degrees. Now you can write the complete answer. I is sine inverse root 2. Instead of sine R1, just write sine 15 degrees. Now this completes your full answer. All right, note it down. Okay, and now same thing if deviation is through the prism. This is last portion from the prism. Then we'll do something else regarding dispersion. If angle is very small, this was the angle of prism. This angle of prism is very narrow right now. See, this is your prism, angle of deviation I plus E minus A. So if you apply Snell's law, no, 1 into sine I will be equal to N into sine R1. So for small angle approximations, what we have studied, that whatever is sine theta, that becomes almost equal to theta. Sine theta will again become equal to theta. So basically in your deviation through prism of small angle, no, the approximation that you will use is I will be directly equal to nr1, right? Sine will get vanished. Similarly, E will be equal to nr2. Now put it in the equation of deviation. So this becomes nr1 plus nr2 minus A. Take n common, that becomes r1 plus r2 minus A. What is r1 plus r2? A, angle of prism, so na minus A. Take A common, that becomes A n minus. All right, write it down. There's one more formula that is known as Cauchy's formula. That is basically application-based questions are asked from this. I'll describe you. See, have a look at the formula directly. You can use the formula, and this is not so very important, but questions will be there. Can be there, questions can be there. This is not very important. So questions will be there in theoretical aspect, like application based questions will be there. So this is a plus b by lambda plus c by lambda square, and it will keep on increasing lambda by q plus and so on. It will keep on increasing. A, B, C, D, these are constants. Lambda is just wavelength. Basically, this formula just wants to tell you that refractive index is inversely proportional to wavelength. So this is important to you. And from here, you'll be having the numericals. Like if you compare the wavelength of red color and violet color, which will be having more refractive index, much greater value of refractive index. So since you all know red has a higher wavelength, so it will be having lesser value of refractive index. So this you just have to deal with your simple Vibgyor logic. This side wavelength increases and n decreases. So you will be having application based questions from here only. Also, like you can do one thing. Lambda of red color is greater than lambda of violet. So refractive index of red is lesser than refractive index of violet. So sometimes what you can do, not sometimes, you actually have this concept that if you take the mean value of the refractive indices of red and yellow, red and violet. So red plus violet by 2. This actually gives you refractive index of yellow color. All right, this gives you the refractive index of yellow color. This is what you use for the Cauchy's formula. Or also one more thing here, deviation you just did n minus 1 into a. So deviation is also related to n. Whatever will be the result of n, that will be exactly the result of n. So if nv is greater than nr, del v will be greater than del r. Means angle of deviation for violet will be greater than angle of deviation for red color. And same thing also, some more application based questions are what? Based on velocity. Velocity is inversely proportional to refractive index. So whatever things are there for refractive index, opposite will be for velocity. Like velocity of red will be greater than velocity of violet. So all these things you can relate. But what I'm trying to say, it's chances are there that this cannot be directly asked to you. But indirectly, application-based questions are there in the exam that can be asked to you. Two concepts you also have. One is the concept of dispersive medium. See, dispersive medium is a medium where suppose this is a dispersive medium. If white light enters this medium, so when the light rays will come out, it will not come single the way it had entered. It will disperse itself because of different speed, different colors, will travel with different speeds. For example, glass, you have glass. If white light is coming and you take a piece of glass, you are able to observe that rainbow formation. No, that rainbow like structure appears somewhere, very slight. That is actually the rays have split. All the rays have split it because of different speed. And opposite to it, you have non-dispersive medium. Here, different colors travel with the same speed of light. For example, right now I'm just putting my hand like this. Here also light rays are coming from this tube light. Light rays are moving here. But since this is the same medium, no, in both the medium, the speed of light remains the same. So I can say the light rays are not dispersing. So non-dispersive medium basically says that different colors travel with same speed. So here you can take the example of glass. Here you can take the example of air. Fine. Now, based upon this, we have a phenomena that I wanted to discuss with you. Rest of the things of this phenomena, we'll discuss it later. But just the definition, let's get over with the definition. That is dispersion. So this only splitting of white light, whenever white light comes through, if you have glass or some material, then the splitting of white light into all of its colors. See, white light is comprised of all the 7 colors of the rainbow that you see, Vibgyor. If you combine all these colors, you get the white light. This white light that you are able to see, this is actually a mixture of 7 colors. So if these 7 colors travel with the same speed, all the colors will move together. When all of these colors move together, you see a single common white light. But if you change the speeds of all of it, then what will happen? Different speeds will be there, different colors will be, you will be able to observe. So right now this white light is coming. All the colors, all the 7 colors are traveling with the same speed here at this point, traveling with the same speed here, traveling with the same speed here. That's why I'm able to see this light as white. All right, this light that I'm able to see, this is white. But if this light is passed through a glass, so for a glass, all the colors, 7 colors will not be having the same speed. They'll be having different speeds. So what will happen? All the colors accordingly to their speed will come out. So fastest color will come out, then the lesser, then faster color, then fast color, then slower, slowest, and finally the maximum value, which is having the slowest. So this phenomena of the splitting of the white light into all of its component colors, right? Whenever this is passed through a refractive medium, that is known as dispersion of light. And dispersion is mainly done with the help of prism. Prism is the best material to disperse light because you are easily able to see everything clearly. That's why this is included under the topic prism. So basically prism is what? Dispersion is what? It's the phenomena of splitting of white light, phenomena of splitting. Just give me a second. So it's the phenomena of splitting of white light. The white light that is coming, so splitting of white light into its component colors. Into its 7 colors also, you can say 7 colors, which are basically component of it. On passing through a refracting medium is called dispersion. Application-based questions are also asked from this, that we'll see later on. Numericals are also asked. So pattern of colors that you see, colors, or you can say colored band, that is called spectrum. So color spectrum we'll see when we'll do prism. Right now, have you understood the definition of prism? You must have seen, even if you have a glass, plain glass you see rainbow formation, rainbow light, not actual rainbow, what is prism, all the 7 colors. That is because of phenomena of dispersion. So we'll see all these phenomena in detail. Till the time noted down, and from Cauchy's formula, I've already told you, from this Cauchy's formula, you have application-based questions. So focus more on application-based question from this part. All right. Whatever things I'm saying, then keep on writing it at the top of your notebook, because at the end, you require these points only, which is important, which one to focus more on. Okay, noted down, text me done, then I'll stop the class.
Teacher, is it lambda 2 or lambda square?
Square, power 1 by lambda n. It keeps on increasing. This is a formula. No need to go into the details derivation of the formula. Just remember the formula. If by chance in 1 marker this formula is asked, you can at least write this. and mention lambda is. Basically, this formula describes us. This is a formula that he invented and he discovered through his experiments. But what basically is of our concern is the fact that refractive index is inversely proportional to the wavelength. So this is square. It will keep on increasing. All those who have completed, you all can leave. Thank you so much.